Picture this. Right now, as you watch this video, every single second that passes represents 22 million years of cosmic history. On this mind-bending timescale, the entire span of human civilization would flash by in less than a blink. We're about to embark on the most epic journey imaginable, from the very birth of our universe all the way to its ultimate fate at the end of time itself. What you're about to witness will challenge everything you think you know about existence. We'll watch stars being born and dying, witness the formation of black holes, and peer into a future so distant that the very concept of time begins to break down. This isn't just science, this is the greatest story ever told, the biography of reality itself. The universe begins in 5, 4, 3, 2, 1. The Big Bang erupts into existence, and from this primordial explosion of energy and matter, everything we know begins to unfold. In those first cosmic moments, gravity becomes the great architect of our universe. From swirling clouds of hydrogen and cosmic dust, it forges the first generation of stars. These massive stellar furnaces burn bright and hot, fusing simple elements into the building blocks of complexity. As they cluster together, vast galaxies emerge, spinning through the endless void of space. But gravity isn't just a creator, it's also a destroyer. When the most massive stars, those 15 times heavier than our Sun, reach the end of their lives, something incredible happens. Their cores collapse catastrophically, creating regions where space and time themselves become warped beyond imagination. These are stellar mass black holes, cosmic monsters with gravitational pulls so intense that nothing, not even light, can escape their grasp. Around these gravitational giants, matter spirals inward, heating to incredible temperatures and creating brilliant jets of energy that streak across space. Yet the interior of these black holes remains forever hidden from us, their secrets locked away behind an invisible boundary called the event horizon. Meanwhile, throughout the cosmos, an endless cycle of stellar death and rebirth plays out. Stars live their lives in a constant battle between the outward pressure of nuclear fusion and the inward pull of their own gravity. When their fuel runs out, they collapse and then explode as supernovas, shining with the brightness of a billion suns. These spectacular deaths scatter the heavy elements forged in stellar cores across space, providing the raw materials for new generations of stars and planets. It was in one such stellar nursery, about 5 billion years ago, that our own Sun was born. Around this newborn star, a disk of dust and debris gradually coalesced into the planets we know today. Among them was Earth, initially a molten hellscape bombarded by asteroids and comets. For the first billion years, our planet was utterly hostile to life as we know it. Volcanoes dominated the landscape and the atmosphere was toxic. But deep in the primordial oceans, something extraordinary was happening. Near underwater volcanic vents, complex chemical reactions began producing the first simple living cells. For 3 billion years, these microscopic organisms were the only inhabitants of Earth. Then came one of the most important developments in our planet's history. Certain bacteria began producing oxygen as a waste product. This oxygen revolution fundamentally changed Earth's atmosphere and paved the way for more complex life forms to evolve. The story of life on Earth is one of incredible resilience and adaptation. Through ice ages that froze the entire planet and mass extinctions that wiped out most species, life found a way to persist and evolve. The Cambrian explosion saw the emergence of complex multicellular animals. Fish conquered the oceans, plants colonized the land, and eventually, mammals inherited the Earth. In the most recent chapter of this epic story, our own species emerged. Modern humans have existed for only the tiniest fraction of cosmic time, yet we've developed the remarkable ability to understand our place in this vast universe and peer both backward and forward in time. But our journey has only just begun. Looking ahead, the future holds changes that will make everything we've witnessed so far seem like a brief prologue. In the coming millennia, Earth's magnetic field will periodically flip, causing chaos for any technology that depends on magnetic navigation. Comets will return on their long orbits, reminding us of our cosmic neighborhood. Sea levels will rise and fall as ice ages come and go, reshaping continents and coastlines. Over longer timescales, the very stars we see in our night sky will begin to wander. The gravitational dance of our galaxy will slowly rearrange the constellations our ancestors knew. Nearby stars will explode as supernovas, and eventually, even our own sun will begin to change. As our star ages, it will gradually grow brighter and hotter. This might sound beneficial, but it will actually spell doom for life on Earth. The increasing luminosity will cause our planet's oceans to evaporate, creating a runaway greenhouse effect that will make Earth uninhabitable billions of years from now. Eventually, our sun will exhaust the hydrogen fuel in its core and begin its death throes. It will swell into a red giant star, growing so large that it may engulf the inner planets entirely. When Earth is finally consumed by its dying parent star, it will mark the end of a 4 billion-year story of life on our world. After this dramatic finale, our sun will shed its outer layers and shrink into a white dwarf, a hot, dense stellar corpse about the size of Earth, but containing most of the sun's original mass. This white dwarf will glow dimly from residual heat, providing only the faint illumination of a full moon to any remaining worlds in the outer solar system. This fate awaits all stars in the universe. One by one, the lights in the cosmic darkness will begin to go out. The universe will enter what scientists call the degenerate era, when white dwarfs and other stellar remnants are the only sources of heat and light in an increasingly cold and empty cosmos. During this era, gravity will continue its relentless work, gradually ejecting dead stars and planets from their galaxies into the void of intergalactic space. Occasionally, stellar remnants will collide, briefly igniting new fusion reactions and creating momentary beacons in the darkness. But these events will become increasingly rare as the universe continues to expand and cool. Over unimaginable stretches of time, even the white dwarfs will fade as their residual heat dissipates into space. They will become black dwarfs, cold, dark objects, more like the corpses of stars than functioning astronomical bodies. The universe will transform into a cosmic graveyard, filled with the remnants of its former glory. Yet even this is not the end of our story. According to current theories, the fundamental particles that make up all matter may themselves be unstable over extremely long periods. Protons, the building blocks of atomic nuclei, might spontaneously decay, causing all remaining matter in the universe to slowly disintegrate into pure energy. This brings us to the black hole era, perhaps the strangest chapter in cosmic history. After all the stars have died and matter has decayed away, only black holes will remain as the dominant structures in the universe. These gravitational monsters will continue to grow by absorbing stray matter and merging with each other, creating supermassive black holes of incredible size. When black holes merge, they create ripples in the fabric of space-time itself, gravitational waves that propagate throughout the universe at the speed of light. These cosmic collisions produce a kind of music, the literal sound of space being stretched and compressed as massive objects spiral into each other at incredible speeds. But even black holes are not eternal. According to quantum mechanics, they slowly evaporate through a process called Hawking radiation. Virtual particle pairs constantly appear and disappear throughout space. But near a black hole's event horizon, sometimes one particle falls in while the other escapes. This causes the black hole to gradually lose mass and energy. For stellar mass black holes, this evaporation process takes longer than the current age of the universe many times over. But supermassive black holes will take even longer, quadrillions upon quadrillions of years. Yet eventually, even these cosmic giants will shrink and finally explode in a burst of energy, returning their mass to the universe as radiation. With the evaporation of the last black holes, we reach what might be called the final chapter of cosmic history. The universe will become a thin sea of elementary particles and photons, all slowly spreading apart as space continues to expand. The temperature will approach absolute zero, and all meaningful activity will cease. This vision of the future depends critically on our understanding of dark energy, the mysterious force causing the universe's expansion to accelerate. Comprising about 70% of all energy in the cosmos, dark energy remains one of the greatest puzzles in modern physics. If it continues to dominate, the universe will expand forever, growing ever colder and emptier. But there are other possibilities. If dark energy weakens over time, gravity might eventually win, causing the universe to collapse back into a big crunch. If dark energy strengthens, it could tear apart even atoms themselves in a big rip scenario. The true nature of dark energy will determine which of these fates awaits our cosmos. Some scientists speculate about potential escapes from cosmic doom. Advanced civilizations might create virtual universes, or even spawn new physical universes through controlled manipulation of quantum fields. If such baby universes are possible, then perhaps our cosmos is just one branch in an infinite tree of realities. There's also the intriguing possibility that universes with intelligent life might have an evolutionary advantage. If advanced species can create offspring universes, then those cosmos that develop intelligence would proliferate, while sterile universes would have no descendants. This cosmic natural selection could explain why our universe seems so finely tuned for the emergence of complexity and life. But if no escape is possible, entropy will march inexorably toward its final victory. The last supermassive black holes will eventually evaporate, bathing the cosmos in one final burst of light before darkness falls forever. After this ultimate sunset, the universe will continue expanding and cooling until even the most basic processes cease. In this far future, the very concept of time may lose all meaning. With no events to mark its passage and no observers to measure it, temporal progression becomes a purely abstract concept. The universe will exist in a state of maximum entropy, completely uniform, completely cold, completely empty. This is our current best guess about the ultimate fate of everything we know and love. Yet it's important to remember that we're still learning about the fundamental nature of reality. Our understanding of dark energy, quantum mechanics, and the deepest laws of physics continues to evolve. New discoveries could completely change this picture of the future. Perhaps the most remarkable thing about this entire cosmic story is that we exist at all. In the vast expanse of time from the Big Bang to the final heat death, conscious beings like ourselves exist for only the briefest moment. We live in a golden age when stars still shine and planets can harbor life, a narrow window between the chaotic birth and the cold death of our universe. From this perspective, every moment of consciousness is precious beyond measure. We are the universe becoming aware of itself, cosmic evolution producing beings capable of contemplating their own origins and fate. In us, the cosmos has developed eyes to see its own beauty and minds to comprehend its own story. As we stand on this tiny world, orbiting an ordinary star in an unremarkable galaxy, we can look up at the night sky and trace our ancestry back to the Big Bang itself. The atoms in our bodies were forged in the hearts of ancient stars and scattered into space by stellar explosions. We are literally made of star stuff, temporary arrangements of cosmic material given the gift of consciousness and curiosity. This cosmic perspective doesn't diminish the importance of human life, it amplifies it. In a universe trending toward maximum entropy and emptiness, every act of creation, every moment of joy, every expression of love becomes a small victory against the inevitable. We are improbable islands of complexity and meaning in an ocean of cosmic indifference. So as we face the far future with its promises of stellar death and universal heat death, we can take comfort in knowing that we've already won the cosmic lottery simply by existing. Against all odds, the universe has become conscious of itself through us. That may be the most extraordinary fact in all of cosmic history. The journey to the end of time reveals both the ultimate insignificance and the ultimate significance of our existence. We are temporary patterns in the cosmic flux, but we are patterns that can think, feel, and wonder about our place in the grand scheme of things. In that sense, we represent one of the universe's greatest achievements: the emergence of meaning from meaninglessness, purpose from purposelessness, consciousness from cosmic chaos. This is our story, from the first moment of the Big Bang to the final silence of a universe at maximum entropy. It's a tale of incredible beauty and ultimate tragedy, of cosmic evolution and cosmic dissolution. But it's also a story of hope, because in this vast and ancient cosmos, we have emerged as witnesses to wonder itself.